Hello dear student, this is Devang Shah from LG Institute of Engineering and Technology. We have been learning the subject basic electrical engineering and we have been discussing the chapter which is called AC circuits, right. So, in AC circuits now my topic is to measure the power of the 3-phase AC circuits. To measure the power of these 3-phase AC circuits, we have started with the wattmeter method, right. So, in our today's session, if we talk about all the contents of this particular part of the chapter, so that we have started with the introduction, that we have discussed the star connection, then we have discussed 3-phase delta connection, and then in our today's session we are going to discuss about the power measurement, right. So, here today we are going to measure the power of a 3-phase AC signal, right. Now, in a 3-phase star connection, 3-phase delta connection, we have discussed about the source part where the 3-phase generation is possible, but in which condition you measure the power. See, the power utilization is always measured at the load condition, right. So, at the destination condition. So, if we generate a 3-phase AC signals, right, then we create either star or delta connection, and that particular generation now we are delivering to the load. Now, this load will be star or delta connection where each arm of this star and delta we have connected a load, and that load in our technical terminology we define as a impedance, right. So, how this is possible, the measurement of this 3 power, this is possible using an instrument, and that instrument is called the wattmeter, right. So, the instrument that will measure the power in any electrical line or any AC line we define as a wattmeter method, right. So, that is nothing, that instrument is defined as a wattmeter, and measurement using the wattmeter we define as a wattmeter method. So, there are various methods that we employ here to find the power measurement in 3-phase AC circuit, right. So, if you see here, there are 3 important methods. One of the method is called 1 wattmeter method, then 2 wattmeter method, and the 3 wattmeter method. So, in this particular diagram you can see there is a symbol of wattmeter where it contains total 2 components. So, here in this symbol it contains total 2 component. One component we define as a CC and another component we define as a PC. Now, CC stands for the current coil. So, that will measure the value of current which is passing through it, right. So, that is a job of current coil. Same way PC is defined as the pressure coil. Now, this pressure coil is ultimately is a one kind of resistance that will measure the drop of voltage. So, that will measure the voltage drop across it, right, since it is defined as a pressure coil. So, that will have the voltage drop, right. So, here if you multiply the current which is passing through the current coil and the voltage drop across the pressure coil, you multiply this and you will find the total power in watt, right. So, that is what the wattmeter symbol is available here, and here you can see there are 3 wattmeter methods. So, each line we have connected one of the wattmeter, and this 3 wattmeter will measure the power in W1, W2 and W3, right. So, ultimately the wattmeter will give you only the measurement of power, right. Now, this is nothing but the multiplication of voltage and current, which is current which is passing through it, and voltage is nothing but the drop across it, right. So, from this particular diagram you can see this is a 3-phase wattmeter method, connected 3 wattmeters in each line, that is why it is defined as a 3 wattmeter method, right. So, here the reading of we define as a W1, reading of second wattmeter we define as a W2, and reading of third wattmeter we define as a W3. So, here W1 is nothing but IR into ERN. So, IR which is passing through the current coil of W1 and the voltage drop across pressure coil of W1 is ERN, which is nothing but the one end of pressure coil is connected to the red phase and another end is connected to the neutral phase, or it is a neutral connection. Same way for the wattmeter reading of W2 is nothing but IY into EYN, and wattmeter reading of W3 is nothing but IB into EBN, right. So, once do the calculation and find the total power or total wattmeter reading, W is equal to W1 plus W2 plus W3, and that is equal to IR into ERN plus IY into EYN plus IB into EBN, right. Now remember this particular equation. So this is referred as a 3 wattmeter method, right. But my job is to look for 2 wattmeter method where only 2 wattmeters are connected in a this 3 phase star connected load. You can see here where there are 2 wattmeters are connected. Now what is the difference of 3 wattmeter method and 2 wattmeter method, right, where we have connected a common connection which is called a neutral line, right. So all this one end of pressure coil is connected to the neutral line, but this is not case with the 2 wattmeter method. You can see here you connect 2 wattmeters and the phase which is left or without the wattmeter, that is your ending point of 2 pressure coils of W1 and W2, right. So from this you can find the wattmeter reading of W1 and W2, and you can just find the final equation. By that way you would understand, even using a 2 wattmeter method you can find the same equation for that what we have received through the 3 wattmeter. This you can be able to find here 2 wattmeters are connected. So my job is to find to do W1 and W2, where W1 having the 2 components. One component is called a current coil, another one is called a pressure coil. So for W1 the IR current which is passing through the current coil, and the voltage drop across pressure coil of W1 is nothing but it's VRB, right. So here this VRB is nothing but one end of pressure coil is connected to the red phase and another end is connected to the blue phase which is left without any wattmeter. Same way for W2. So you can be easily find this particular equation. So let us start and derive the equation for a 2 wattmeter method. So here you can see the current which is passing through W1 is IR and the voltage across W1 is VRB, right. So here from this I can be able to write the wattmeter reading of W1 is equal to IR into VRB, right. In another sense you can also write W1 is equal to IR into VRB is equal to IR in bracket ERN minus EBN, right. Same way if you look for the wattmeter reading W2 and this W2, the current passing through is IY and the voltage drop is VYB. So the final equation you will find the W2 is equal to IY into VYB, and that is equal to IR in bracket EYN minus EBN, right. If I am finding the total power measurement, that is W is equal to W1 plus W2, then my equation would be IR in bracket ERN minus EBN plus IY into EYN minus EBN. So altogether you will find IR into ERN plus IY into EYN minus EBN into IR plus IY, right. I consider now this system is a balanced system. So from this star connection I can say IR plus IY plus IB is equal to 0. So from this you can be able to find IR plus IY is equal to minus IB, and that minus IB you will put in a first equation. You can be able to find W1 plus W2 is equal to IR into EYN plus IY into EYN minus IBN in bracket minus IB, and that is equal to minus minus plus. So that is equal to W1 plus W2 is equal to IR into ERN plus IY into EYN plus IB into EBN. Now see this same equation you can already find using the 3 wattmeter method. So using 2 wattmeter method you will find even the total power. That is why we employ this 2 wattmeter method, where there is a saving of 1 wattmeter. So it is a particular cost saving, right. So same way here P1 is the power absorbed by load L1, P2 is the power absorbed by load L2, and P3 is the power absorbed by load L3. So here my total power is nothing but W1 plus W2. Now this is the same equation that we found using the 3 wattmeter method, right. Now if we talk here in terms of the phasor diagram, and I am looking for 2 vector equations in terms of W1 and W2 to find the power factor. So let us say next terminology is to find the power factor by this particular phasor diagram. So wattmeter reading W1 is equal to the current which is passing through W1 is equal to IR, and the power difference across the W1 is nothing but VRB, and that is equal to ER minus EB. So now the reading of W1 from this phasor diagram, here you have to find the relationship of current which is passing through current coil and the potential difference or voltage drop which is available at the pressure coil, right. So, from this the wattmeter reading W1, that is equal to nothing but IR into VRB, and if I want to find the phase difference or a phase relation of IR vector and the phase relation of VBR vector, you can be able to find from this phasor diagram, where this particular phasor diagram, if you see this, VRB is nothing but ER minus EB, right. So, from this particular phasor diagram, you can see here W1 is equal to IR into VRB, where if you find this particular vector and you will find the relation of angle versus the relation of IR and VBR is nothing but the 30 minus phi phase relation of IR and VRB, right. So, here the W1 is equal to VRB into IR into cos 30 minus phi. Now, same terminology go for W2 IY and VYB, right. So, from this you can be able to see from the phasor diagram the relation between this two vector is nothing but cos 30 plus phi, right. So, from this two equation, W1 is equal to IR into VRB into cos 30 minus phi, and W2 is equal to IY into VYB into cos 30 plus phi. Now, you take the summation of this two particular equation, you will be able to find the total voltage, which is nothing but root 3 times of VL into IL cos phi, right. So, from this you can apply this particular equation, and you can see here W1 plus W2 is equal to VLIL cos 30 minus phi plus VLIL into cos 30 plus phi. Now, here you are taking cos plus cos. So, it is the complete equation like VLIL in bracket cos 30 into cos phi plus sin 30 into sin phi plus cos 30 cos phi minus sin 30 sin phi. So, once you remove the sin sign, you will be able to find 2 VLIL cos 30 cos phi, right. So, and cos 30 is equal to root 3 by 2. So, from total W1 plus W2 is equal to root 3 times of VLIL cos phi. Now, this is the same equation that we will you already found during the power calculation of 3 phase star and 3 phase delta, which is root 3 VLIL cos phi. By that way you can also find total power, which is again it is a 2 wattmeter method, right. Now, further we will find the power factor from this equation, then we will have a W1 and W2. So, we are, if I am taking here 1 minus W2 and use the trigonometry, you will find it is VLIL sin phi, right. Now, taking the ratio of W1 minus W2 and W1 plus W2, you can see here the ratio from this VLIL sin phi divided by root 3 VLIL cos phi, where sin phi divided by cos phi is equal to tan phi. So, the complete equation, if I am converting into a subject of tan phi, so you can see here tan phi is equal to root 3 times of W1 minus W2 divided by W1 plus W2, and I carry forward this particular equation, and you can see the total cos phi, that is nothing but the power factor is a cos phi. So, power factor is equal to cos phi, that is equal to tan inverse in bracket root 3 W1 minus W2 divided by W1 plus W2. By this way you can also find the power factor, right. Based on this terminology, further if we find the effect of power factor with this power or wattmeter readings of W1 and W2. So, let us take W1 is equal to VLIL cos 30 minus phi and W2 is equal to VLIL cos 30 plus phi, where we take the value of phi is equal to 0. For both the cases, W1 and W2 are same and positive. If we take phi is equal to 60 angle, then you will find W1 is equal to root 3 times of VLIL and W2 is equal to 0. So, here only one wattmeter method reads the 0. That means, here value of power factor is equal to 0.5. So, the last case where you find phi is equal to 90, for both the cases you can see here the W1 and W2 is 1 half VLIL and minus 1 half VLIL, and once you do W1 plus W2, here the value is becomes the 0. So, one of the wattmeter reads the negative, right. So, here from this 3 particular cases you can conclude that for the first case, for the power factor between 0 to 0.5, and now one of the wattmeter reads the negative. Then if when the power factor is 0.5, is the circuit efficiency is 50%, one of the wattmeter reads 0. When power factor lies between 0.5 to 1, then both the wattmeter readings are positive, and if the power factor is equal to 1, you can see both both watt meters are equal, same and positive, right? So this is for the case number 1 where power factor is equal to 1, case number 2 where power factor is equal to 0.5, and case number 3 when power factor is between 0 to 0.5, right? So this is what about the power measurement in a 2 watt meter method or in a 3-phase AC circuits, right? So what we have discussed, we have discussed about the 3 watt meter method, 2 watt meter method, and the power factor calculation of this 3-phase AC circuits, right? Thank you, dear students. If you have find any queries, please write in a comment box. Thank you very much.